Okay, good morning, students. Today in our class, we are seeing the new chapter what we have seen in our previous class, that is mapping the data warehouse to a multiprocessor architecture. Okay, for that we have seen the parallelism, the types of parallelism. These two types of parallelism have been given in the previous class, that is horizontal and vertical parallelism. Okay, now today we can see data partitioning. Okay, what is the need for parallelism? We can do multi-processing operation at the same time. Okay, multi-processing at the same time. Okay, and for that we have specified what two parallelism methods. Okay, here in the data partitioning, it is a key component for effective parallel execution of data based operation. Okay, that is data partition is the key component, and partition can be done randomly or intelligently. Okay, here partition can be done random. What is the need for having a partition is the data have to be partitioned on the basis of some execution. Okay, due to for executing it what the database operations for effective parallel operations. Okay, for that purpose they are partitioning the data. Okay, and here the data portioning, which includes random data stripping across multiple disks on a single server, and another option for random portioning is round robin fashion. Okay, it is partitioning in which each record is placed on the next disk assigned to the database. Okay, round robin fashion is what? Whenever your memory is full, the remaining data of that memory will be the data will be placed on the other next disk. Okay, right? Which there from there the data or the records will be what taken. That means it will be partitioned and store the record in another disk. And here an intelligent partitioning assumes that DBMS knows where a specific record is located and does not waste time searching for it across all disks. Here during partitioning, during the data partitioning, the data will be stored among the different disks. Okay, so when a user will go for accessing, the data which may be spread in different disks will be what accumulated, and by what intelligent partitioning. Okay, and here the DB must knows it. Okay, where a specific record is located and where and does not waste time for searching for it across all disks. So using the intelligent partitioning, this method will access all the records from different disks immediately and produce the result there. Okay, let us see what is the intelligent partitioning. That is hash partitioning, key range partitioning, schema partitioning, user defined partitioning. Okay, let us see first one as what is hash partitioning. And it is used to calculate the partition number. Okay, that is the hash value based on the value of the partitioning key for each row. Okay, that is a hash algorithm which is used to calculate the partition number based on the value of the partitioning key for each row. Each row and this algorithm will calculate a key. Okay, there is a hash value for each record, and it will based on the key it will identify the each row. Okay, And this is a kind of what, a partitioning. And key range partitioning. What do you mean by key range partitioning? Here rows are placed and located in a partitions according to the value of the partitioning key, and that means all rows with the key value from A to K are in a partition 1 and L to T on a partition 2 and so on. Okay, that is, there will be assigned, a key will be assigned, a value will be assigned, and a certain key value will be given from A to, for example, if it is from A to K, it is a partition 1. It will assumed as a partition 1, and remaining L to T, and it will maybe partition 2, and T2 is set as what, partition 3, and so on. So a value what they have been set as a value A, B, C, D up to K are in a partitioning 1. Okay, and another remaining a partition 2, and later partition 3, and so on. Okay, and schema partitioning. What is schema partitioning? This is an option not to partition a table across disk. Instead, an entire table is placed on one disk and another table is placed on a different disk. Example, this is useful for small reference tables that are more effectively used when replicated in each partition rather than spread across partitions. Okay. Okay, this is a option. This is not to partition a table across disk. Okay, it will not partition the table beyond the disk, but an entire table is placed on one disk, another table is placed on a different disk, and another table is placed on another disk, and so on. Okay, so each table which will be within a particular disk. Okay, and there will be a reference table will be there for more effectively used to when replicated in each partition rather than spread across partitions. Okay, in order to access easily by the users, they will give a what, replication. Okay, the reference table. Okay, small reference table will be there on which table this particular data records will be on, or which table which have been stored in a particular disk, on another kinds of tables, sometimes of tables which is stored in another disk, and so on. Okay. This is a what, a schema partitioning. And next one is a user defined partitioning. It is a partitioning method that allows a table to be partitioned on the basis of a user defined expression. Okay, that means state codes to place rows in one of 50 partitions. That means they will create a what, a some certain codes, and to place rows in one 50 partition. First 50 you'll have a particular 50 rows, and another partition have another rows, and so on. Okay, for that we are used but user defined what, partitioning there. Okay, next title, database architectures for parallel processing. Okay, first one is the parallelism, that is relational data is technology for data warehouse, where we have studied the parallelism. And the second one is data partitioning, and next one is next title is database architectures of parallel processing. Okay, there are 3 DBMS software architecture styles for parallel processing. That is shared memory or shared everything architecture, or shared disk architecture, and shared nothing architecture. Okay, here these are the three kinds of architecture which have been given. Okay, let us see first one as what? A shared memory architecture. Okay, what is there in the shared memory? It is a traditional approach to implementing a RDBMS, and it have multiple PUs. Okay, personal processor unit. Okay, multiple processor unit will be there. Okay, and in this shared memory architecture, the SMP systems and the DBMS assumes that the multiple database components executing SQL statements communicate with each other by exchanging messages and data via the shared memory. Okay, all processes have access to all data which is partitioned across local disk. Okay, here in our example, um, here is an example. A picture have been given, that is shared memory architecture. Within this shared memory architecture, here what is they have been given, all the memory. That is the key point of this approach is that a single RDBMS server can connect, can potentially utilize all processors. Okay, for that they have been used a global shared memory there. Okay, and here, and it will access all memory and access the entire database, thus providing the user with a consistent single system image. Okay, we have a consistent, a single system image is there, and we have using a multiple database component which will execute SQL statements, communicate with each other by exchanging messages and data via the shared memory. Okay, and all processes have access to all data which is partitioned across local disk. Okay, here the lower part of this is what the these all are the local disk. These all are the local disk. It will be shared by the what, from the global shared memory. Okay, the globally the data will be stored anywhere. Okay, and from there each unit processor unit will access that data for what, a speed. Okay, that means multiple users will use the processor to process that at the same time, and in order to get speed, what they have been used, what, a processor unit there. Okay, and the parallel processing advantages of shared memory system are given here. Okay, that means many memory access is cheaper than intermode communication, and this means that internal synchronization is faster than using the locked manager. Okay, and the shared memory systems are easier to administrate than a cluster. Okay, here the shared memory systems are easier to administer than a cluster. And here on the disadvantages they have been given is scalability is limited by bus bandwidth and latency and by available memory. Okay, scalability is limited by bus bandwidth and latency with an available memory. Okay, next one is this is the two advantages and the disadvantages here. And next one is shared disk architecture. Okay, here it implements a concept called what, loosely coupled. Okay, that means this architecture implements a concept of shared ownership of the entire database between RDBMS servers, each of which is running on a node of a distributed memory systems. Okay, that means there will be a number of what uh, surveys will be there, RDBMS surveys will be there, and this surveys will each other they will what serve, or each other they will share the datas. Okay, that means the datas will be shared among the disk. That's why we will say it as what shared disk um, architecture. At the same time, it may not share between nodes. Okay, it cannot be shared between nodes, but the memory, the service, if there is different service, the service will be shared there. Okay, and here communication over occur over a common high speed bus, and each node has access to the same disk and other resources, and a node can be an SMP and if the hardware supports it, and the bandwidth of the high speed bus limits the number of modes of the systems. Okay, okay, here each node has access to the same disk and what other resources. Okay, and at the same time a node can be an SMP if the hardware supports it. Okay, here this is a distributed shared disk architecture. Okay, here in this architecture there is international connection network is there, and various for example they have given process unit, and they have a what a local memory, and they have been shared by the global shared disk subsystems. Okay, and here the global shared subsystem different surveys, these are the various surveys, these are the various surveys on different area, and it will be shared among the what the surveys. Okay, not the nodes. Okay, and here the complexity of the necessary coordination performed by the DLM is hidden from users and applications. Okay, here what they have been seen, a cluster have been formed. The above figure is composed of multiple tightly coupled nodes. Okay, nodes are the systems what the users have been used, and here a logs manager will be there. Distributed log manager is required, and the examples of loosely coupled systems are wax clusters or sun clusters. Okay, here the clusters what they have been said is what wax, that means a distributed log manager DLM is required there. Okay, for the loosely coupled systems, and the memory have the capacity to share among the nodes. Okay, and at the same time each node have their own data, the storing capability, that is a cache memory is there, and this cache consistency must be maintained across the nodes, and the log manager is needed to maintain the consistency. What is the need for a log manager here? That means if a particular process is going for a say more than one process is going for accessing the same data, but the log manager will log the certain process to stop, lock it, and that means once a particular data is accessing, it will log, and after accessing then only it will release the log. Okay, so here a certain log manager is needed to maintain the consistency. Why means in order to maintain the consistency. And next one, it is there is an additional overhead in maintaining the logs, and ensuring that the data caches are consistent. Okay, the one there is an what a log have been ensure that the data catch are what consistent, and the performance impact is dependent on the hardware and software components. Okay, and here the performance is dependent on hardware. Why means according to the um, high performance hardware and the software, or high configured hardware and software will be used there. Okay, and such as the bandwidth of the high speed bus through which the nodes communicate, and the DLM performance. Okay, here the performance impact is dependent on the hardware and the software components, such as the bandwidth of the high speed bus. Okay, so bandwidth, if there is a high speed bus, there will be no what overhead will be there. That means we can send and receive the data very speed. And here there are what are some advantages of a parallel processing, advantages of this shared disk systems, which are given here. That is, shared system disk system permit high availability. Okay, that is, all data is accessible even if one node dies. Okay, and that means even if one node dies, there will be no what the others will take control of the other nodes. Okay, that's why. So it will be cannot be we cannot say it is a what the network is what failed if even if one node fails, as usually the process will be going on. Okay, and this system have the concept of one database, which is an advantage over shared nothing systems. Okay, and here with when which is an advantage. Okay, it have a concept of one database. Okay, that means it will store in a form of a database, and it have a one database, and maybe for sharing the for sharing purpose, they have been giving as what as a single database there. Okay, and shared disk systems provide for incremental growth. Okay, for in order to increase the growth of this process, they have been used what a shared disk. And next one, the disadvantages of this shared disk system is internode synchronization is required. Okay, there must have a synchronization between the nodes, involving DLM overhead and greater dependency on high speed internet. Okay, that means there is a need for high speed internet. If there is any low speed internet, it may lead to what a very the speed will be less, and very less performance will be there. Okay, so they need a high speed internet. It is not a disadvantage, but they have been given this one among the disadvantages. And if the work is not partitioned well, there may be high synchronization over. Okay, there is multiple processor, so the work should be equally divided into for the all processor. In case if there is not partitioned properly, it may what say as what a synchronization overhead. That means it may take more time to access the particular data there. And there is an operating system overhead of running shared disk software. Okay, there must have a separate operating systems for what running shared disk what as software there. Okay, so these are the various uh, tasks which have been given in our what shared disk architecture. Okay, so today we have seen the shared memory architecture and the shared disk architecture. Okay, next class we can see shared nothing architecture, and some combined architecture there. Okay. So today we can conclude today's class. Okay, tomorrow we can see the next part of this subject. Okay, thank you.